Hello again, Pre-Calc. So I included both pages for this in the video just to kind of point out a few things. So here's kind of a reference page. You have your arithmetic series, which actually that is for your sequences. And then you also have, here is for the series, to find the sum of the first n terms. Then you also have your geometric sequence and your geometric series, as well as the infinite series. Again, remember that R has to be less than 1. I guess they have it right there. What we're going to look at today are binomial series. And I know some of your A2A teachers may or may not have covered Pascal's triangle. It is something, unfortunately, that sometimes gets left behind. And this is what we are going to be looking at today, because Pascal's triangle is totally cool. All right, hopefully you've also had a little bit of probability, which I'm not sure if you have. I think you might have had some in geometry. So this is Pascal's triangle. If you're going to create it, it's basically ones on the outside. And then when you get to this third row, notice it becomes 1, 2, 1. What we've done is added 1 plus 1 is 2. So you still have ones on the outside, but then to get these middle numbers, you add the two numbers above. So 1 plus 2 is 3, 2 plus 1 is 3. We put ones on the outside, and then 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, etc. This gives us Pascal's triangle, which has so many different applications. To start off with, this first row is actually called row 0, and it is the coefficient of the expansion of a binomial. Bi means 2, so 2 terms raised to a power. So if I raise a plus b to the 0 power, what would I get? I'd get 1. If I raise a plus b to the first power, I get 1a plus 1b. So what you're getting here are the coefficients of each term. Look at, here's your quadratic, a plus b squared. That would give me 1a squared plus 2ab plus 1b squared. And then it continues on. And this is the beauty of, without having to expand and distribute and FOIL, you can quickly come up with the terms of a binomial raised to a power by using this binomial theorem. Couple things, because I can't help but go into this in Pascal's triangle, that are always fun to kind of highlight. Notice here, and again, this keeps going. There's no end to Pascal's triangle. But notice here, if on this diagonal, you have your counting numbers, 1, 2, 3, 4, 5, etc. The first number is considered, just like that first row was row 0, that first entry is considered your, what would I like to call this, position 0. And then this 5 would be in the first position, second, third, fourth, and there would then be a 1 out here as well. And that would be in the 5th position. We're going to be looking at this. And now what I have here off to the side, this is important for what we're doing. Hopefully you did permutations and combinations at some point before this class, which is basically sort of used in probability. So we have, if you were to calculate combination 0, choose 0, the answer would be 1. And you have this on your calculator, which I guess I'll have to show you at some point how you can do this. 1, choose 0, 1, choose 1. These, so if you notice in row 0, in the 0 term, it's 0, 0. Here we have row 1. This is the 0 position. This is the first position. Here's row 2, the 0 position, the first position, the second position. And then the coefficients that would give are here in Pascal's triangle. Okay, So the binomial formula, binomial theorem, which is usually more recognizable, is this. It says that I can find a particular term or a particular expansion, a plus b raised to the n power. Remember, this is your sigma notation, which means a sum. So you're expanding it based on this sum. N, so this right here, the n over r is another way of writing n choose r. A raised to the, which is your first term, to the n minus r, b to the r. Notice if you add those two to the exponents, you would get n. The two should always add up together. Here is the n choose r, and this is what that means. In probability, combinations was when order doesn't matter, and I'm not going to go into the whole probability review because it's not really relevant to what we're talking about today. So let's get into the actual notes. So we have here a series, which we've just looked at, is a sum, which we know. So when you expand a binomial expression, you get what is called a binomial series. Again, a series is a sum of a list of numbers. So a plus b to the fifth, we know, expands like this. Now, that's what the beauty of this is. We can use the binomial theorem to expand this very quickly without having to FOIL and distribute. As I said, a couple things I want to point out. So if this is raised to the fifth power, notice that every single one of these exponents add up to 5. That's one way, so there's a 1 on top of that a. That's one way you know how you've done it. If you've looked at this before, notice the a starts at the highest 5 and then descends. A to the fourth, a cubed, a squared, a to the 1, a to the 0 would be in this last term. And then the last term, b, starts at its highest at the last term and descends going forward. B to the fifth, b fourth, b cubed, b squared, b to the 1, b to the 0. All right, some things to kind of notice. You always have one more term because of that 0 position. You always have one more term in your expansion than the power that you are expanding. Each term has a degree of n. That's what I just kind of went over. The powers of a start at n and decrease. B starts at 0, starts at b to the 0, and increases by 1 each term. And the coefficients can be found either as a combination or in Pascal's triangle. All right, so let's do one. So here we have x minus 2 to the y to the fourth. So again, let's look at Pascal's triangle. 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Because this is to the fourth power, remember, this is row 0. So row 1, 2, 3, this is row 4. You're always finding the row when you look at the counting numbers. So the 4, that's the one we want. We want that row 4. Okay, so we're going to expand this. What I always start with, since it's to the fourth power, I know I'm going to have 5 terms. So I like to kind of draw it out. 1, 2, 3. I'm going to run into things, aren't I? I'm going to erase that. 1, 2, 3, 4, 5. And I don't worry about trying to simplify things right now. So the first thing is I'm just going to put these coefficients. There's a 1, a 4, a 6, a 4, and a 1. And that just comes directly from Pascal's triangle. Then I take that first term, which is x, and I raise it to x to the fourth, x cubed, x squared, x to the 1, and at this time I'll just write it, even though you usually don't, x to the 0. Now I'm going to start with the negative 2y, and I start it back here. Negative 2y to the fourth, negative 2y cubed, negative 2y squared, negative 2y to the first power, and this would be negative 2y to the 0 power. I tend not to write the 0 power when I'm actually doing it, but as an example, I'll kind of work it out. Now, because you have a negative here, because you have subtraction, it does mean that every term is going to alternate positive and negative. That first term is going to, because I know that equals 1, the negative's not going to affect anything. So to the first power, this will be negative, so I don't have to worry about my negatives anymore. Second term will be positive because you're raising it to an even power. Third term will be negative, and then the fourth term will be positive. So if I have a negative, I tend to just go back and then alternate my signs. And then the next thing I do before I'm totally done is I simplify my coefficients right underneath. So here I have 4 times 2, which is 8. Here I have 6 times 2 squared, because remember that squared has to distribute. So 6 times 4 is going to be 24. Then I'm going to have 4 times 8, 2 cubed, which is 32. And then I'm going to have 1 times, oops, we took care of that negative. 2 to the 4th is 16. So I'll just put that down there. And now I'm ready to write my final answer. So this first term is going to be x to the 4th minus, and I've already figured out my coefficient, so I don't have to deal with the numbers anymore. So I have 8x cubed y to the 1st plus, and again I've already figured out my numbers, so this will be 24 x squared y squared minus, already got the numbers, this will be x to the 1st, whoops, forgot to write it down though, that would help, minus 32 x to the 1st y cubed, and our last term is 16y, okay, there's a 4 up there, kind of got lost, it's right there. Okay, and that would be your final answer. And you might think, oh my god, that's a lot of work, but okay, take some time and just expand x minus 2 to the 2y, x minus 2y, x minus 2y, so have fun with that. Meanwhile, I'm going to move on. All right, so it's a tiny bit of work, but it's a lot easier than doing it old school. All right, so that's one way to expand a binomial. So you're using Pascal's triangle and the binomial theorem. Now, one of the things that the binomial theorem allows us to do, and did I write it? I'm going to write it down again. Let me put this down here. Your binomial theorem is this. So you have n choose r times a to the n minus, oh, I did r, okay, it doesn't matter, just a variable, and then b to the r. Okay, so this is r. So we want to find the 8th term of the binomial series that comes from expanding this. Now notice that that is to the 12th power, which means I'd have 13 terms. It's like, that is not something that I want to sit there and expand and then say this is the 8th term. So let me just kind of set this up for you. I wouldn't usually do this, but I just want to emphasize. So 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, dot, dot, dot. We're going to go out 9, 10, 11, 12. So remember, this is when r is 0, that first term. That's position 0. So position 8 is actually way back here. So it's going to be, oh wait, the 8th term, is going to be right here. That's my 8th term when r is 7, because you also have when r is 0. So it always adds 1 term onto it. So the first thing I'm going to do is I am going to figure out the coefficient that would be in Pascal's triangle. Now, how would I do it? Well, I know that n is 12, and I'm looking for r, in this case, is going to be 7. That's what would be in the 8th position, in the 8th place, all right? So what is 12? Choose 7. On your calculator, if you have a TI 83, 84, any one of those, you would hit the math key, and then you would go over and you would choose probability, And if you look down the list, number 3 in the list is NCR. So what you would do first is you would actually enter in 12 on the screen, then you would go through that process, then you would enter in 7, and the answer to that would be this incredibly huge number, which is now, oh, you know what? Let me do it on my calculator because I don't think I wrote it down. So I hit math, which is on the left-hand side of your calculator. Scroll over to probability, and there's number 3. Now, one of the newer calculators, you can just enter it, and it lets you enter in the little boxes. It kind of depends how new your calculator is. So I can just go ahead and bring it up. This equals 792. All right, so what's going to sit here in this position? Well, Pascal's triangle would give us 792 for the coefficient. And then remember, it's going to be the first term, which is 3 raised to the n minus r. Well, n is 12, r is 7. So I'll write it out this time. 12 minus 7. And then the next term is going to be a negative 2x raised to the r, which is 7. So when we work this out, it's going to be 792 times 3 to the 5th power times negative 2 to the 7th power times x to the 7th power. And when you work that out, it's going to be a lovely negative, is that going to be million? Yes, negative 24,634,368 x to the 7th. Now, once you do this a few times, it goes a little bit faster. Obviously, I'm trying to explain the process, so that takes a little bit of time. But basically, this is your A value. This is your B value with the negative there. This is the N. And the R, well, this is going to represent the 8th term is going to be R. Plus 1, I don't know how to say that. The 8th term minus 1 is going to be R, okay? Because remember, you have position 0. So you're actually in the 7th where R is 7, because that would be 8 places out. And this was your answer. All right, I hope that makes sense.